Okay, testing. All right, looks like I'm live. Okay, so this is going to be a really gentle introduction to React and TypeScript. Some obligatory social proof to start with. 46% of NPM users are using TypeScript. The latest State of JavaScript survey also showed 47% of users using TypeScript and 34% wanting to learn. So if that's you, then this session is definitely meant for you. Major libraries, including libraries at Facebook, are moving to TypeScript, like Jest, Expo, React Beautiful, D&D. In fact, all of Atlassian is moving to TypeScript. So Jira as well, and Google also uses TypeScript in every product. So those are very, very compelling stats. And my goal here is to show you how to get started with TypeScript very, very easily and quickly. So here I have an empty folder. Well, I'm going to make an empty folder, and we're going to kick off npm create React app, and now I'm just going to call it project 3. And then we'll add a TypeScript flag. So it's been TypeScript support has been built into Create React app as of 1.2.1, I think. And that's a direct result of Babel upgrading to Babel 7, and then Babel preset TypeScript being enabled for Babel 7, enabling all this good stuff downstream. So this is a chain of dominoes that is happening. So this bootstraps a typical Create React app project. You can verify that by just hitting yarn start. And while this is starting, I'm just going to walk you through the app. If you look at app.tsx, you can see that it looks basically like a regular. Just naggle my windows. Okay. Basically like a regular JavaScript React app. There's nothing in particular that looks like it's has anything to do with TypeScript. But in here, you'll see that we have installed @types/react and @types/-react DOM. So those are the relevant things we're going to make today. So the first thing we're going to try and make is a function component. That's the simplest component in React. And we're going to make an awesome button. Everything in TypeScript is called .tsx. They don't accept the .ts extension for avoidance of confusion. You can import React from React as per normal, but in legacy TypeScript, you want to import star as React. So for compatibility reasons, I'm going to do that as well. I really don't like the theme I have going on here, so I'm going to try and see if this is better. I don't like it either, but whatever. Okay, so let's also define a button component, and that just has a button, and it says hello world. I'm going to export default button. Awesome. Now I'm going to hit back to my app.tsx, and I'm going to import the button. So far, I've written 100% valid JavaScript code, right? Component/button. Okay. And then I'm going to replace all of this stuff. Right, so save that, and we have hello world over here. Very nice, right? Okay, so now we're going to start writing our first TypeScript related stuff. So what if I want to take a string, right, from pass in a string as a prop? Actually, let's call it a text or something like that. And then dynamically display whatever the label is passed here. But hang on, I have a issue here, and that's because I now have an implicit any type. And I've specifically disallowed any types are kind of the first type you fall back on that just match any. And here you want to define the types of your props. So I'm gonna declare button props, for example, and I'm gonna say I expect that my text is gonna be of type string, and I'm gonna pass that in as a colon right next to my button. And let's just turn this into a multi-line thing, and that will be fine. So everything here works, but my app is still failing to compile. And the reason is because property text is missing in button props. So where I've used it, so now I expect a text button, right? But I've said that over here, I haven't given it the props that it wants. So this is a very, very fast feedback loop telling me what's wrong with my app. So here, if I say hello world, I'm going to restore everything to a proper state. So that's very good. I can also make my string optional. So for example, if I make it optional here, and I destructure and add, you know, hi world, I can also get rid of this, and it would be fine. So this is how you make an optional, make properties optional just by adding a question mark over there. All right, so that's all well and good. And now let's add another thing to do with styling. So let's just call this the state of the button, and this will also be a string. And it will just put a little nice border around the button. So let's just call it a border. It will destructure it as well. Destructure state, right? And then we'll just say 5px solid state equals to success, question mark, green. If it's not success, red. And then finally pass the style object into the underlying button. Yeah. Okay. Oops. Now I've made my state required as well. So I'm going to go back and enter a new state, for example, success. And now I have a button with no text, so I'm just going to give it hello world. And the reason I only have this error is basically because I marked my text prop here optional. If I marked it not optional, it would have yelled at me before it compiled. So I have this new state variable prop here, in which I can also type in error, and that will give me an error. But if I mistype success, that will also look like an error because of the way that I've done my ternary if here. So what are the ways to do that? What are the ways to address this? Right, I can write a test for that and kind of make sure a runtime test, for example, or I can use an enum, and that's something that exists only in TypeScript, where instead of a general string category, I can just say I specifically only want either the success literal string, or I can say error literal string. So now it gives me an error and says, oh, I have misspelled type success, which is a literal success with one S, is not assignable to type success with two S's at the end. So I can fix this error, and now it works. And this type checking is so good that even if I mistype my own code within my component, so for example within here, this would also not be accessible to them. So that's very good checking, and obviously this applies for reducers and switch statements and all sorts of impossible states that you might forget to check for, and now you just employ the type checker compiler to do for you. All right, so buttons need to be able to be clicked, so let's just give it an onClick prop. I don't know what the type of this is, so I'm just going to call it a function. And I'm going to start using it in my code. So onClick here, and I'm going to say onClick. Oh, and here it tells me function provides no match for the signature event, mouse event, HTML button element, mouse event. So the buttons onClick takes a variable of this type of this sort of generic type. That's defined by the maintainers of the React typings. And here I've only given it function, which is a very generic typing, which is not tight enough for these guys. So the best way to deal with this is to redefine, is to change what I've already defined. So if I just click into here, and I click there, that makes the error go away. Except I now have the error in a different place over here because I haven't implemented the onClick. You see how just writing this back and forth makes writing components across an app very, very easy. So let's say over here I can say console.log. Actually, I don't want to say console log because that's not very helpful. I guess I could. All right. So I have console log here, and it's logging out the event, synthetic event. All right. So let's actually give it a just to show you the power of autocomplete. So the event handler here on click takes an event, and now when I type in e dot whatever, it gives me all the all the properties of the event based on the underlying button. So for example, e.clientx, I can console.log that. And now wherever I click on the button, so here I have 132, 106, 126, 145. This actually shows the the X position of my mouse button. But the point is that the drop down, just from knowing what the type of this event is, gives it all these properties that inside the IDE. So even if I mistype the property name, it will check for me and it will fail to compile because this is an invalid property name. Whereas in JavaScript, this would be undefined, right? And you try to use it, and you get sort of all sorts of annoying errors. Okay, so that's your component names. Let's turn this into a stateful component. So what that will require is turning this into a class, extends extends React.component, and then throwing this in a render method. And then I have to pass this in as props as well. Okay, but now I need to pass these props because right now the error is reading property state does not exist on whatever. So now I need to give it the props, and I can pass it in the props using the generic syntax notation right next to the React.component constructor. And here I fixed everything into a class component as well. So you can also annotate state. So for example, button state equals to click count number, for example, and I'm going to pass it in here, button state, initialize the state, right? So and call it click count 0, and every time I click, I can say for example, I can say, for example, this set state, click count this dot state count plus 1, and then I can pass the onClick parent onClick to that as well. So let's console log this dot state as well. So every time I click now, the internal button has a console log with the click count, and then I also have my mouse X. So now we have a stateful component with error checking, and this is very helpful, for example, in the set state situation when you're trying to use the callback version of the set state. And this is valid JavaScript, but this is not valid TypeScript. And the way that you detect that is you type your state, and that should detect this, I think. Well, it doesn't really. Okay, so that's not actually gonna set state on anything, and that is a bug I don't know how to fix. I should probably try to learn how to fix that. All right, so the next thing I want to show you is, now that imagine we've gone through and made our app and we have a functioning app. Now we also want to make at the same time a reusable component library, and this is where TypeScript starts, the tooling of TypeScript starts to really pay off dividends. So I'm going to install something called docz. First I need to there's a small bug around docz, so I need to install this little resolution thing. Don't worry about that. And then I'm gonna yarn add docz with the default theme, and here I'm gonna start explaining how we can add comments to the components. So my props, for example, they can take comments. This is the text of the button, state of the button, and then it just says click me. Okay, so nothing changed, but I've added comments to these props in line. So let's just say I'm using a reusable component library from whatever I'm writing, right? I can hover over each of these props and actually get a result once my node modules start resolving. This is very slow. Okay, this is the text of the button. This is the state of the button. This is on click. Click me, it says. Okay, so let's actually see that in documentation. So I'm going to do a little bit more configuration. .zrc.js. I'm going to add some boilerplate to accept TypeScript. And then I'm also going to give it a string, a npm script. I think that's all I need. So yarn docs. Oh, and I need MDX as well. So, and then I can start writing documentation. So let's just call this button MDX. MDX is a format that mixes React components with Markdown. So you can write your documentation. So here I've documented my awesome button component. It takes a prop table, and imports the button. It has some Markdown here, but then it also has some React here. So it gives you a live playground. And then you can print out the props table of the button and even more documentation in Markdown. So let's click on this and see it alongside. I have to restart it because I started my MDX component late. So it should hopefully work. Yeah, so here's a documentation for my button. I've got a title, I've got some text, I've got the working button. I haven't supplied it on click yet, so that's a problem for it. We also have live editing going on, so you can say hello, the world React, and see how the success and error states change as you type. So this is a awesome playground for all your components that you're building. So you can build it outside of the context of your main app, which is very nice. And you can also see the props table. You can annotate some defaults, for example. So if I go here and I say, all right, maybe I have a default text. I can annotate over here that I do have a default text. And just say hello world, for example. And that should pop up over here. Hello world. So it's really up to you, and the tooling all comes as a direct result of the strict property checking of TypeScript, which is super nice. Okay, so what else is there to tell you? I've taught you a lot, but let's just do a little summary of the talk so far, and I'm just gonna add it here. Hopefully works. All right, so summary of the talk. More stuff to check out. So I've introduced to you the basic types and how they're used in React, but there are advanced types where you can write generic typed logic, and you can pull types from components. You can pick them, partial states of them, and then use them, change the readability of them, extract types, all sorts of good stuff. There's also community libraries like Typesu, and then for every popular library, there's something indefinitely typed, which is one of the most popular GitHub repos. TypeScript is also not perfect. Here's some things that people struggle with. For example, generic type logic, which is very complex. So for example, if you can read code like this, yeah, it's not simple. You're definitely learning another language on top of JavaScript, but it is a fantastic way to continue to bet on JavaScript. Linting, there used to be issues with TS linting versus ES linting, but the TypeScript team has basically doubled down on ESLint now. So hopefully the ecosystem will be better in terms of what linting solution that you should choose. And then bike shedding, because there's multiple ways to type things, they're all correct given some context. This may cause additional hurdle on your team to think about like what you really want out of your components and your types. But all in all, just don't forget why you want to use TypeScript. And it's the same reason why you want to test your code, which is correctness. You want to achieve some level of correctness for whatever is in your head to be actually what the machine does. And the way I kind of put it is kind of like this: like we all pursue correctness. This box is everything that's possible in code, but we don't want everything possible. We just want the small circle of stuff that is exactly what we want. And the two ways that we use to achieve this, to make sure we declare our code and do as good as possible. And two ways to ensure that we're correct is by testing. So we write individual point solutions. Here it should fail, and that's good. And then here it should pass, and that's good inside the circle of things that we want. Or you use types where you just draw general circles around the things. And the better typing your solution gets, the smaller the circle until it overlaps with the exact circles that of your code. So that's a really nice way to think about typing. Unit integration tests test classes of happy and unhappy paths. Type checking excludes categories of unhappiness. And for more on that perspective, I highly recommend this Gary Bernhardt's talk on ideology, which is actually about more stuff than that. It also, the other two ways of looking at TypeScript is that it's increasing the feedback loop. So think about how many errors I ran into as I was coding this stuff, but I didn't have to build it. It just told me inside the IDE. So you have more errors up front instead of less errors further down the line where they can be harder to detect. So that's also very nice. And the last way to look at it is that it's like a free team member for pair programming, which is really helpful, and you don't have to pay for it. Like it's just a really annoying pair programming partner that just looks over your shoulder and just says, "Oh, you spelled this wrong. Oh, you like passed in the wrong proper and whatever." So it's very, very helpful for writing React apps at scale. So some calls to action for me. If you want to learn more, I maintain a cheat sheet for beginners to get started in React and TypeScript. It's fairly popular, and it's got all the important stuff that you need. We walk through some of it here as well. If you want to talk about TypeScript and React, the subreddit, which I moderate, has 88,000 of us, and we all like React and TypeScript very well. And lastly, contact me on Twitter for a recording of this talk, and I'd be happy to take any questions that you want. All right, cool. Thank you very much for watching.